Hello dear student, welcome to my class. Last class we discussed what is physical quantity, and there are two type of physical quantity. First one derived physical quantity and second one fundamental physical quantity. And what is fundamental? That means it is independent of other physical quantity. So it is independent quantity, and similarly there is another type of physical quantity that is known as derived physical quantity. So what is derived physical quantity? Just I am remembering you. A derived physical quantity is that of physical quantity which can be derived from other physical quantity like fundamental physical quantity, like volume, area, clear volume, area, velocity, force, etc. These are the example of derived physical quantity. And next one we discuss about unit and what is the measurement process, and next we discuss about different type of system of unit, that is force system of unit, MK system, CGS system, FVS system, and last one which is most important system of unit, that is known as system of international unit or international system of unit, which we discussed last class, that is SI system of unit. It consists 7 fundamental unit, and these fundamental units are first mass, length, time, temperature, amount of substance, electric current, and luminous intensity. These are most important, and this important fundamental quantity that is belongs to SI system, which is 7, and after that there is 2 supplementary physical quantity, and this supplementary physical quantity, first one we have plane angle and second one solid angle. So this is 2, and the sum of 7 plus 2, which is 9 unit, which is under the system of international unit or international system of unit. Clear? So these are the fundamental unit in international system. Now we will discuss here what should be the characteristic of a SI unit. So here first we will discuss the characteristics of SI unit, international system of unit. So these are most important characteristic which may ask in your council examination. So the first important characteristic, that is 1. Now this characteristic of SI unit, first it is a metric system unit, metric system of unit. So what is metric system of unit? If we write a unit in terms of the power of 10, then we can say this system is under the condition of metric system. Suppose if we want to write, if we take one example, suppose there is a distance like that is 1000 kilometer, and we can write this term, that is 10 raised to power 3 kilometer. This is known as a metric system of unit. Clear? And we can derive this is MK system. In MK system we already know the length can be measured in kilometer, and this kilometer which can be converted into CGS system. So this is MK system, or we can write here it is 10 to the power 3. Here kilometer, we already know 1 kilometer which is equal to 10 to the power 3 meter, and this is known as metric system. If we use this concept here, then which is here, that is MK system. If you want to write in case of CGS system, because this is MKS, meter, kilogram, second, and this is also we can write here, this is also meter, MK system. Or if you want to write 1 meter equal to 100 centimeter, or in metric system you can write 10 to the power 2 centimeter. Clear? So if we use this relation here, 1 kilometer equal to 10 to the power 3 meter, and 10 to the power 3 into 1 meter, which is equal to 10 to the power 2, which is centimeter. This is CGS system. Clear? So this relation, or if we solve this relation, then we can write it is 10 to the power 5 centimeter, which is you can replace here 1000 kilometer, which is equal to here 10 to the power 3 into 1 kilometer, that is 1 kilometer, which is equal to 10 to the power 5 centimeter. So 10 to the power 5 centimeter equal 10 to the power 8 centimeter. This is CGS system and this system is MK system. So these are the concept of matrix system of unit. So this is important characteristic of a SI system. Clear? So next will come another characteristic of SI system, that is known as, this is first point and there is another point, second point, and it is coherent system of unit. It is coherent system of unit. So what is the meaning of coherent system of unit? We have to take one simple idea to find unit of a physical quantity. Suppose you already know there is a physical quantity force and its SI unit, that is Newton. If you write in symbolical form, then force can be represented in one single term or symbol, that is N. And if you want to write the value of 1 Newton, then force F equal to, we already know that is F equal to mass into acceleration. So we have to write 1 Newton force which is equal to, and here which is mass, we have to take here in SI system, that is 1 kg, because mass or kg is the unit of mass. So you can write here 1 kg into acceleration, and you already know acceleration which is equal to velocity upon time, and the unit of velocity which is equal to meter per second divided by second and equal to meter per second square. So you have to write here 1 meter per second square. Now here the term we have to use 1 and here the term also we have to use 1. At that time this system is known as coherent system of unit. So 1 Newton force apply on a particle whose mass is 1 kg and which moving with a acceleration of 1 meter per second square. This is known as coherent system of unit. That means we have to use here 1 and then we get 1 Newton force. Clear? Similarly, we will know power equal to work by time, and we already know the unit of work which is joule divided by second. Now we have to find the unit of power. We already know that is watt. If we want to calculate 1 watt, then we can write 1 watt which is equal to joule. We can write here 1 joule divided by 1 second. So we have to place here 1, we have to place here 1, then we get 1 watt. You cannot place here 2, 3, 4, etc. Clear? So only one quantity you have to place here which is 1, and here also 1, and we get 1 watt, and this system is known as coherent system of unit. Clear? So by multiplying and dividing by the other physical quantity, you can get a new physical quantity in the system of coherent system. Clear? So these are the important characteristic. Next, third characteristic, and it is rational system of unit. Rational system of unit. So what is the meaning of rational system of unit? Here we have to use one unit for same kind of physical quantity. We have to use here only one unit for same kind of physical quantity. So what is same kind of physical quantity? You already know. Actually work, energy, or you know different type of energy. Suppose there is kinetic energy, potential energy, and then gravitational energy, electrical energy. Clear? All these units have different term in, if we because we have fundamental or basic quantity, that is mass, length and time. So we have to represent unit in terms of mass, length and time. So here kinetic energy already know that is half mv square, and here if you want to use unit, this is constant quantity and which don't possess any unit and dimension, but here m. For each m means mass, so we can write here kg into mv, and velocity meter per second square, and meter per second whole square. So this term is known as the unit of kinetic energy. Similarly, you know the potential energy mathematical formula, that is mgh, and m means mass, we can write here kg into what is g. G is here acceleration due to gravity, which we will discuss your gravitation chapter. So you have to remember this concept here, only g, and g is here acceleration due to gravity, and its unit, that is meter per second square, into h. H means height from reference level. So here height is measured in meter. So these are the unit of the potential energy. And you can electrical energy also you can use, that is potential, which is equal to W by Q, and you can write W equal to VQ. You have I think you have related this, or you have acquainted with this term, W equal to V and Q. And what is V? V is here volt, and here Q is the unit of Q is here charge. Then we get the unit of, that is electrical energy. And you know or I think you know about 1 electron volt. So what is the value of 1 electron volt? Here 1.6 into 10 to the power minus 19 joule. Clear? This is the unit of 1 electron volt. So 1 electron volt, which is equal to 1.6 into minus 19 joule, or here this is unit volt into charge or volt into coulomb. Here you can write volt into coulomb. So actually electrical energy is also one type of energy, gravitational energy, potential energy, kinetic energy. These are one type of energy. So it is difficult to remember all this formula or all this unit. So we have to take only one unit, which is convenience method to remember. So that we have to use here one unit for same kind of physical quantity, and here kinetic energy, potential energy, gravitational energy, and all the energies, and we can take one unit, that is known as joule. Clear? Or there is another one unit, heat. And heat can be measured, actually heat is the type of energy, and you already know 1 calorie, which is equal to 4.2 joule. So before it is used calorie, after that in SI system it is used joule, that means 4.2 here joule. Clear? Because it is heat is also the physical quantity, and it is the physical quantity of energy. Clear? So these are the third point of a third characteristic of SI unit. So in this case, in rational system we have to deal with only one unit which have same kind or which have same physical quantity. Clear? So next one, the next characteristic of SI unit, that is known as, it is internationally accepted, or this unit widely accepted in international system. So last one, fourth number characteristic of SI system, it is internationally accepted. Clear? So these are the characteristic of SI unit, and these are most important characteristic in nature. Clear? So you have to remember one by one step how a characteristic of unit can be write. Clear? So next we will start another concept of the remaining part of physics, that is unit and measurement. So here we will discuss about abbreviation of power of 10. So what is abbreviation of power of 10? So we have to write here abbreviation of power of 10. Clear? Okay. Suppose, and it is easy method and convenience method. So here suppose there is a term that is 100 meter, and there you can write 100 ohm. So this is the unit of resistance we'll discuss in second year class. Then 100 can be write, or 1000 ohm which can be write, that is 10 to the power 3 ohm. Clear? And we have to define a convenience method, and that convenience method which is easy to describe this physical quantity, or this quantity can be write in the abbreviation, or in the abbreviation of power of 10. So there is two type of abbreviation. First we will use here multiples, and here it is prefix. Next its symbol. You have to remember one by one step. This is important and this is basic. You have to remember this concept. Clear? So now let's start. Multiple, and here multiple, which multiple means power of 10. Now we have to write here, that is 10 to the power 1. Here the power of 10 or power 10 to the power 1, and its prefix we can write here, that is deca. This is prefix. Clear? And 10 to the power 1 deca, and its symbol, that is D. Next 10 to the power 2, then 3, then you have to increase the power of 3, that means 3 and 6, then 10 to the power 9, 10 to the power 12, 10 to the power 15, etc. Clear? So this is multiples, that means power of 10. Now here 10 to the power 2 is here deca, and here that is hecta. Deca, hecta. Next that is kilo, deca, hecta, kilo, and here that is mega, and then giga, that is tera, and next peta, or you can write 10 to the power 18, that is exa. Clear? These are multiples, and these are the prefix of this multiple. You have to remember this term, and their symbol here DA, and hecta H, next kilo small k, and mega M, and giga small g, and here kilo, this is capital letter we can write here according to the name of scientist. So giga capital G, tera T, and peta here capital P, and next exa is here capital E. Clear? Okay, and this is multiple. Now we have to write here sub multiple. Sub multiples and their prefix and its symbol. Clear? So first we have to write here the sub multiple which is negative sign. Here we have to use negative, and here we have to use the power of 10 which is a positive quantity. So here first we have to write there -1, and then -2, and then -3. Then you have to raise the power by increasing 3, 3, 3, and same thing here, only positive quantity plus 1, 2, 3, 4, 5, 6, 1, 2, 3, 6, 9, 12, 15, 18. Similarly you can write here 10 to the power -6, 10 to the power -9, 10 to the power -12, 10 to the power -15, and 10 to the power -18. Clear? And now we have to write it prefix. Here 10 to the power -1, we can write here deci, that is centi, and here milli, micro, nano, deci, centi, milli, micro, nano, pico, femto, etto. Clear? these are the prefix of the submultiples. Now we have to write its symbol. So here deci means small d, and centi small c, and milli small m, and then we can write here micro, and the symbol of micro mu. Clear? You have to read this mu. Mu means micro and its value 10 to the power minus 6. Next nano, and we have to use here the symbol small n. Next pico, small p, this is small p, and that is femto, f, and last one that is a to a. So these are the symbol of this submultiple, and these are the symbol of multiple. So you have to remember one by one multiple and submultiple. So how can we remember it? If you revise it daily, then you can revise, you can remember all these things, or what is multiple and what is submultiple. Deca, hecta, kilo, you have to remember by 3 3. Deca, hecta, kilo, mega, giga, tera, peta, exa. Deca, hecta, kilo, mega, giga, tera, peta, exa. Similarly, deci, centi, milli, micro, nano, pico, femto, atto. Clear? These are the multiple and submultiple which is important in physics. So you have to remember this concept, or you have to remember this value, what is prefix, what is symbol, and what is multiple and what is submultiples. Clear? And now how can we use this multiple and submultiple here? So if you write some example regarding this multiple and submultiple, now let's start one example. Suppose there is given a physical quantity, that is resistance, and you know the resistance, unit of resistance, that is ohm, and given that is here 1000 ohm. Clear? Now we have to use this symbol, or we have to use this multiple or submultiple here. Then we can write his 10 power 3 ohm. And this is not convenience method to represent again and again, so we have to use a convenience method here, 10 to the power 3. Now use this concept, this is multiple, and here multiple 10 to the power 3, and its prefix is here kilo, and symbol that is small k. So we have to use this concept here, that is 10 to the power 3. We can write in place of 10 to the power 3, which can be write, that is kilo. So we can write here 1, because here 1 kilo, 1 kilo ohm, or you can write symbol 1 kilo ohm. Clear? So in this way we can use this abbreviation, or we can use this multiple or submultiple to convenience method. Clear? Or you can write another one example. Suppose if we write same thing, resistance or voltage, which is equal to 10 to the power minus 5 volt or 10 to the power minus 6 volt. Clear? So now we have to use here, this is 10 to the power minus 6. Now this term, this is multiples and its prefix, that is micron, micrometer. So we have to use here, which is equal to 1 microvolt. This is convenience method, or symbolically you can write 1 microvolt, which is equal to, you can write, if there is given 1 microvolt, write the value of 1 microvolt, which is equal to 1 micro and its value 10 to the power minus 6. We can use here 10 to the power minus 6 volt. Clear? So in this way you can use this multiple and submultiples. Clear? Okay. Next we will start practical unit, and that practical unit which is important, and this practical unit we use day-to-day life. Now discuss about this practical unit. So first we will start practical unit of measurement for distance. Clear? So first we have to study practical unit. Practical unit. First we have to start practical unit. And first we have to start basic idea about practical unit, that is distance. So we already know distance is measured in meter, kilometer, centimeter, etc. So the first practical unit, first we have to deal with here, that is a large distance. Large distance. First we will discuss, that is astronomical unit, and here astronomical unit, and it is symbolically you can write AU. So what is the meaning of astronomical unit? We cannot use the convenience method, that is kilometer and centimeter meter in all the things, so we have to use some practical unit for convenience. Suppose you already know the path of the revolution or orbital of earth, like elliptical, this is not spherical shape, and here there is two focus point. We will discuss here the chapter gravitation. Suppose there this point which situated and this point represents sun, and here this is earth. Now earth revolve in a orbital path, or elliptical path around the sun. Now this distance is known as distance from sun to earth. So how can we measure this distance? We have unit, that is kilometer, meter, centimeter. We cannot use this unit because this distance is large distance, 10 to the power something. So at that time we have to use some practical unit here, and the practical unit is known as 1 astronomical unit. So what is 1 astronomical unit? It is the mean distance or average distance. It is the mean distance between earth and sun, or it is the mean distance of earth from sun, is known as astronomical unit. And you have to remember the value of astronomical unit, that is 1 astronomical unit, which is equal to 1 AU, and 1 astronomical unit is here, that is 1.496 into 10 to the power 11 meter. By using this large distance value, you can measure the distance of sun to earth. So this distance is known as 1 astronomical unit. So this is practical, first practical unit. Second, 1 light year. 1 light year. So what is 1 light year? You already know the speed of light in vacuum, that is c equal to speed of light, or you can write here speed of light, and which is represented by c, and here c is equal to 3 into 10 to the power 8 meter per second. That means if we take the light to 1 second, then it travel a distance which is equal to 3 into 10 to the power 8 meter. Suppose this distance, the light travel this distance from A to B in 1 second, which is equal to 3 into 10 to the power 8 meter. But here we have to find 1 light year, the distance traveled by light within 1 year, and this is for 1 second. Another 1 second this distance. Similarly, we have to calculate 1 year. The distance traveled by light in 1 year is known as 1 light year. And you already know the velocity. How to find velocity? That velocity equal to distance by time, and here distance equal to velocity into time. We have to use this concept to find 1 light year. So its definition, it is the distance travel by light in 1 year is known as 1 light year. So how can we calculate this distance? And here distance equal to, we can write this distance equal to velocity into here time, and here velocity means velocity of speed, velocity of light. which is equal to 3 into 10 to the power 8 meter. Now use this relation here. It is 3 into 10 to the power 8 meter per second into time means 1 year, and here this is time which is equal to 1 year. Now, and this distance is known as 1 light year. So you have to remember this concept. Light year is the concept, or light year is the unit of a distance. It is not the time. So 1 light year which is equal to 3 into 10 to the power 8 meter per second into 1 year. Now you have to use the value here to find the value of 1 light year. So 1 light year which is equal to 3 into 10 to the power 8 meter per second into 1 year, and here we can write 1 year which is equal to 365 1 by 4 days, or simply you can write 365 days, or you can write 365.25 days. Now 3 into 10 to the power 8 meter per second, because here second and this is meter, so you have to convert it day into second. So we already know that is 1 day, it is 24 hour. Now use this relation here, 665 1 by 4 into 1 days, and here that is 24 hour, that is 3 into 10 to the power 8 meter per second into 365 1 by 4 days, which is equal to 24 hour, and 1 hour which is equal to 3600 second. If you convert it into second, then you can write this relation here, that is 3600 second, and 1 second, another is second cancel, the remaining term, that is 3 into 10 to the power 8 here meter, and into 365 1 by 4 into 24 into 3600 meter. Clear? If you solve this relation, then we get a approximate value, that is 9.46 into 10 to the power 15 meter. This is the value of 1 light year. Clear? So you have to remember this relation, which is 1 light year, and it is the distance covered by light within 1 year, and its value which is equal to 9.46 into 10 to the power 15 meter. Clear? Now another practical unit for measurement of large distance, that is known as parsec. So what is parsec? Now let's start. Parsec. So now let's start another practical unit, last unit of distance, that is parsec, or it is also known as, it is parallactic second. Parallactic second. Parallactic second is the unit of distance. It is the unit of distance, and it is the largest unit of practical system. So what is parallactic second? It is the distance at which the angle subtended by an arc, the angle subtended by an arc, the angle subtended by an arc of length 1 astronomical unit. Suppose we already know how to measure angle. Suppose there is two line and this is theta, and theta is known as angle, and angle can be write that is angle which is equal to arc upon that is radius. If the distance between sun and earth, suppose this is earth and sun, here distance which is equal to 1 astronomical unit, and we have to find here the value of parallactic second, the distance at which angle subtended by an arc and its length is 1 astronomical unit at the time, the radius is known as 1 parallactic second. So here suppose this distance, if you draw diagram here, this is arc and this distance is here 1 astronomical unit, and this point is suppose sun. So this distance sun to earth which is 1 astronomical unit, and here it is the distance at which the angle subtended by an arc, this is arc, of length 1 astronomical unit which is equal to 1 second, and here representation of 1 second which is equal to double. So this is 1 second. Now we have to find here angle, and this angle is theta. Now we have to find here this angle is theta which will be 1 second, and this angle which is equal to 1 second. Then this distance or this radius is known as parallactic second. So suppose this length and this is angle subtended by this arc of length 1 astronomical unit, and this angle suppose here that is theta, and theta is here suppose less greater than 1 degree, and you have to know the basic idea about degree and minute, that means 60, or you can write 1 minute which is equal to 1 by 60 degree. Clear? So 1 minute which is equal to 1 by 60 degree, or 1 degree which is equal to here 60, you can write 60 minute. So in this way 1 second which is equal to 1 by 60 minute. Clear? That means if we take here this total angle which is equal to 360 degree, now divide it its 4 quadrant, and this quadrant consists of 90 degree, and now this total angle is here 90. Now divide it into 90 parts. So one part is consist of 1 degree. Clear? Now again suppose if we zoom this part or zoom this angle, I can write here this angle is which is equal to 1 degree. Now again divide this 1 degree which is equal to 60 part. So this is, in this case, that is 60 part. Now this angle is known as 1 minute, but we need here 1 second, and now again if you zoom this angle, then this angle is which is equal to 1 minute. Now divide this angle again 60 part, and 1 angle is known as here 1 second. We need this angle. Clear? So when the arc subtended angle, when this angle theta, if we again increase this length, then this theta decrease. This is suppose theta 1 and here theta 2. If you observe this point, then here theta 3. Now here theta 1, theta 2, theta 3. Which angle is greater? Now in this case. Clear? So at that time, if you want to decrease the length at a particular length, suppose this the particular angle, suppose this angle, if this angle which is equal to 1 second, at that time this distance is known as parallactic second or per second. Clear? So what is the meaning of parallactic second? Means the distance at which, means this distance, angle subtended by an arc of length, this arc of length 1 astronomical unit is 1 degree, which is equal to 1 second, and this angle is here now 1 second. Again if you write this diagram here, and this angle which is equal to 1 second. At that time this arc distance equal to 1 astronomical unit, then this radius or this distance is known as 1 parallactic second or 1 per second. Clear? And its value, you have to remember the numerical value of parallactic second. You have to just remember this value here. So 1 per sec, which is equal to 1 astronomical unit divided by 1 second. Clear? So here if you solve this relation, we can write 1 per sec, which is equal to 3.08 into 10 to the power 16 meter, and this is the largest unit to measure distance and largest unit for practical system. Clear? So this is per sec. If you compare light year and the value of, if you compare light year 1 astronomical unit, 1 AU, 1 light year and 1 per sec, then we can write 1 per sec greater than 1 light year, which is greater than 1 astronomical unit. This is the practical unit for measurement of large distance. Clear? Now we will discuss smaller unit. That means suppose we have to measure the radius of atom, radius of nucleus. So in this case we have to use some basic unit which is convenience for the measurement, and we cannot use this unit for measurement of atomic radius. Yes, clear? So these units are suitable to measure the star to star, planet to other planet, like this. So now we will start smaller unit. This is smaller distance or smaller unit, smaller particle units. First we have to discuss here 1 Fermi. 1 Fermi. So it is used for measuring smaller distance, and this Fermi is you can use for measurement of atom, and its value 1 Fermi. You have to remember its value 1 Fermi, which is equal to, or 1 FM equal to 10 to the power minus 15 meter. Clear? Because suppose this is atom and its radius, and this radius of atom which is equal to 10 to the power minus 10 meter, and inside the atom there is a nucleus. See, nucleus, and this radius suppose small r, and the radius of nucleus which is equal to 10 to the power nearly equal to 10 to the minus 14 or 10 to the minus 15 meter. So to measure the radius of nucleus we have to use smaller unit. We cannot use kilometer, meter or large unit, that is parallactic second, light year. So in this case we have to use smaller unit which is convenient to measure the distance of radius of nucleus. So in this case we have to use 1 Fermi. So value of 1 Fermi which is equal to 10 to the power minus 15 meter, and another smaller unit, that is 1 angstrom, and it is represented, that is A to the power 0, 1 angstrom, and this is also used for the measurement of atom or radius of atom. So in this case its value you can write 1 astronomical unit which is equal to 10 to the power minus 10 meter, because the radius of atom which is equal to 10 to the power minus 10. Now you can use this angstrom to measure the radius of atom. Clear? So these are the smaller unit of these are smaller unit for measurement, and there is another unit, smaller unit you can write, that is nanometer, which is equal to 10 to the power minus 9 meter. We already discussed in prefix in sub multiple 1 nano which is equal to 10 to the power minus 19, so it will be minus 9, so 1 nanometer is equal to 10 to the power minus 9 meter. So these are the practical unit for measurement of distance, and this is smaller unit to measurement the physical quantity. Clear? Now let's start mass, practical unit which is used day to day life, that is mass. So we already know the unit of mass, that is kilogram, gram, milligram, etc. So now discuss here practical unit for mass. First we will discuss large unit. Now just we have to remember this unit. If we want to measure the mass of large mass, then we have to use some practical unit which is convenience to measurement. So here the unit of mass which is equal to, you can write here 1 ton. 1 ton or 1 metric ton, which is equal to 1000 kg, or you can write this 10 to the power 3 kg. Clear? Again another unit, it is 1 quintal. I think you are acquainted with this term, that is 1 quintal equal to 100 kg. Clear? So these are the unit, or another unit you can remember, that is 1 pound, and its symbol, that is LB. 1 pound which is equal to 0.4536 kg. These are the practical units of measurement of mass. So you have to remember all these things to measurement of mass, and you can measure for smaller unit, this is bigger unit to measurement of mass, and this is smaller unit. For smaller unit you have to remember 1 to 2, 3 units. Suppose you have to measure the atomic size or atomic mass, then you have to remember the unit of mass, that is 1 AMU, 1 atomic mass unit, which is equal to 1.66 into 10 to the power minus 27 kg, and this atomic mass unit which is 1 by 12 mass of carbon atom, and it is 66 and T12. Clear? So this relation actually derived here, and this is 1, you have to remember just this relation, 1 atomic mass which is equal to 1.66 into 10 to the power minus 17 kg. Suppose you have to measure the mass of electron, then how can we measure this mass? So here we have to use, that is electron, mass of electron equal to 9.1 into 10 to the power minus 31 kilogram. Clear? By using this concept we can measure the mass of electron. Similarly you can measure the mass of proton, which is equal to 1.67 into 10 to the power minus 27 kilogram. Clear? So these are larger unit of mass, and these are the smaller unit of mass. Clear? So in this way you can measure the weight, or you can measure the value of physical quantity by using this concept. Around with axis with certain angular velocity, we will discuss later, that is angular velocity omega. And what is solar day? Solar day means it is the time taken by earth to complete one rotation, about its axis, about its own axis, with respect to the sun. Clear? This is earth, and the time taken to rotate, the time taken by earth to complete one rotation about its own axis, and it is denoted by 1 day. And here the solar day which is equal to 1 day, or 1 day equal, that is known as 24 hours. Clear? Next we can write another term here, that is solar year. So what is solar year? It is the time, taken by earth to revolve around the sun, or when suppose earth start this point and complete one revolution around the sun, and it is known as, that is solar year. And it take solar year which is equal to, it take 365 1/4 days. Clear? This is known as solar year. Or you can remember for small unit of measurement of time, you already know hour, minute, second. So now let's start another smaller unit. Smaller unit which is equal to, that is 1 sec. And this 1 sec which is equal to 10 to the power minus 8 second. This is smaller unit or measurement of small time. This is the smaller, and this is practical unit which you use day to day life. Or another unit you can use here, that is leap year. This is bigger unit. So what is leap year? If the year which is divisible by 4 and the year which is divisible by 4 and the month of February will be 29 days. Clear? And this is known as one leap year. So these are the concept regarding practical unit which we need to use day to day life, and these are we already discussed here. What is the characteristic of international system of unit? And you have to remember important thing, that is multiple and sub-multiple. This is most important factor in physics. So you have to remember all the concept which we discussed here. Clear? Now next class we will start another topic of your 11th chapter. Clear? Thank you all.